All right, so welcome back to everyone. A very, very warm welcome to all of you, my dear students. A very warm welcome to all of you. So, guys, I am your physics educator, Dr. Umashankar, and I am here to continue with the journey that we have undertaken together to complete the physics for NEET 2024. Okay. Okay, so guys, in this session, I am going to come up with the one more concept of the vectors. So, till the last session, what we have done, so till the last session, guys, okay, up to the last session, so we were dealing in the vectors in Cartesian, okay, we were dealing with the vectors in Cartesian, okay, dealt with the vector in the Cartesian. We have seen that how do we do a addition, subtraction, okay, finding magnitude, and all these things we have done. And in the last session, guys, we were talking about the position and the displacement vector. So in the last session, we were speaking of the position and the displacement vector. Okay, so we come to understand about the position and the displacement vector in the last session, that what is position vector, what is displacement vector, how from the position vector we can get the displacement vector. So all these things we have done in the last session, right? All these things we have done in the last session. So guys, in the last session what we have learned, so let me give you a brief or overview. So see, we have learned, let's suppose there is 2 points A and B. Okay, there are 2 points A and B on this coordinate axis, X and Y. And if we join this origin we are considering as our reference point. So if we are joining this origin from if we are joining this point A from the origin, that is going to be your position vector of point A. Position vector has something. What do the position vector do? So the position vector gives you the position of any point. Okay, position of any point in two-dimensional, three-dimensional coordinate system. Now, similarly, the position of the point B from the origin, it is given by the position vector R2. It is given by the position vector R2, and now this is your displacement vector. This is your displacement vector. Okay, AB. Okay, and what was the displacement vector? So we write it as OB minus OA, that is the position vector of this R2. OB we are calling as R2, that is final point position vector, minus initial points position vector. So the difference between these two is going to give you the displacement vector. I hope it is right. Right. Okay. So this much we have seen in the last session. Now let's try it. So we also come up into that three-dimensional also. Okay, so last session we have done all this. So anyone who is watching this video and haven't watched the last session of vectors, please go and watch that session. That is going to be, very helpful to you. So let me come up with a question. So let's say on just to, so in the last session we started with the three-dimensional also, and just like that we are going to do with it. So on a horizontal flat ground, let's say on a horizontal flat ground, a person is standing on a horizontal flat ground. A person is standing at a point A, at a point A. Okay, point A. Now, see, very, very interesting question it is. At a point A. Now, at this point, he installs A 5 meter long, he installs a 5 meter long pole vertically. 5 meter long pole vertically. Now he moves 5 meter towards east and then 2 meter towards north. 2 meter towards north and reaches a point B. Okay. There he installs there he installs another 3 meter long. There he installs another 3 meter long vertical 3 meter long vertical pole. A bird flies from top of the first pole to the top of the top of the second pole to the top of the second pole. Okay. Find magnitude find magnitude find magnitude of displacement of the bird. Find magnitude of displacement of the bird. Okay, now let's try to do this. I'm very sure we can do it. So let me give you some options here. So let's suppose A is root 33, B is root 35, okay, C is root 37, and D is root 39. Can you please do it? I'm very sure we can do it if we try to. Please go for it. Please go for it, beta. Hello, Shivesh. Welcome to the session, my dear. Welcome to the session. Let's try this question. Let's try this question. I'm very sure we can do it. Please go for it. Please go for it. Please go for it. I'm very sure we can do. Any answer? It's very, very simple. Now see, please understand this. Please understand this. See, displacement vector, position vector. So in questions like this, you have to imagine the position of some point. Once the position is established or imagined perfectly, you are going to get your answer very, very quickly. Okay, you are going to get your answer very, very quickly. Now, it says on a horizontal flat ground, a person is standing at a point A. Now, at this point, he installs a 5-meter long pole vertically. Now, let's try to make this. So, here in this, there are three dimensions. Okay, now let's suppose this is a plane. See, this is a little bit tricky. Why so? Because see, the screen or the page on the copy is a two-dimensional thing, right? But in this kind of a question, we have to try to think three-dimensionally. Now, on a horizontal flat ground, a person is standing at a point A. Let's suppose this is that point A. Okay. Now, at this point, he installs a 5-meter long pole. So let's consider the direction. So this is X, this is Y, this is Z. Okay. Now someone is standing at point A. Now he installs a pole, 5-meter long pole. So when he installs a 5-meter long pole, this is gonna be the pole now, parallel to this Y. Okay, so let's suppose this is 5 meter. Let's try to think in this way. This is 5 meter. Okay. Okay. Now now he moves 5 meters towards the east. Now from A, it moves towards the east. That means he moves along the X. He moves along the X. Okay, very well. He moves along the X and then 2 meter north. Okay, 2 meter north from this point. Now, if you see this north, if you see this north, so this is vertical, this is east, so this is north, na? This is north, na? So basically, when you are moving towards the north, so actually, when you are moving towards the north, you are moving in this plane towards the north, right? So you are moving along the jet and you are moving 2 meter and basically you are moving parallel to minus jet direction. Do you agree to it or not? Please answer me. You are moving parallel to this minus jet because from this point you have moved 2 meter west. So when you are moving this 2 meter west, beta, when you are moving 2 meter west, that means you are moving towards this point. You are moving towards this point. Okay. Now what happened in the question? It says it reaches the point B. Okay, so this is your point B. Okay, now what does it say? Now there he installs another pole 3 meter long. Now at this point B, he is installing another pole which is 2 meter long, 3 meter long. So it must be like this 3 meter long. Okay, and this pole must be parallel to this Y. This pole must be parallel to this Y. Okay. Now a bird flies from the top of the first pole to the top of the second pole. The bird flies from the top of the first floor, the top of the first floor. So this is the first position. Let's suppose this is given by 1 to the top of the second pole. So let's suppose this is 2. Okay. Or let me name them. Let me give them some name. So let's suppose this is P, this is Q. Now bird flies from P to Q and you need to find the magnitude of the displacement of the bird. So this is the displacement of the bird na, given by this vector PQ, given by this vector PQ. Do you agree or not? Now don't you feel this is the displacement vector, okay, which is joining two positions? This is what we call as the displacement vector na? Something which is joining two positions. Okay. Okay. So what is this displacement vector, beta? What is the displacement vector? So we understand that we can write it like this. So OQ vector minus OP vector, that is the position vector of the final point minus position vector of the initial point. Position vector of the final point minus position vector of the initial point. Now what is going to be the coordinates of this P and Q? So see this coordinate P. So this A is your origin. Let's consider A as your origin, right? Because all the movement is started from here. So this is your reference point. So here X is 0 and this pole, this is Y. So that is 5 and this is 0. So this is going to be the coordinate to it. Do you agree or not? Okay, now similarly, what is the coordinate to Q? So in Q that we have moved 5 in X, then the pole is 3 meter high, and we moved in minus Z. So it is we moved minus Z in minus 2. Okay, minus 2. So what are the coordinates of this Q? So it is 5, 3, minus 2. Okay, so in physics, these kind of things happens a lot. They try to give you, data or the question in the way like the bird flies from this pole to another pole. So you may be worried that how, what is happening, bird is flying and all this thing is happening. So don't get worried, don't get afraid. Now, what is going to be this vector? So this is OQ is 5i plus 3j minus 2k, and what is this position vector OP? This is 0 of I, this is 0 of I, okay, plus 5 of j plus 0 of k, plus 0 of k vector, okay, unit vector k. Now from here can I write, 5 of I minus 2 of j minus 2 of k. Okay, so this is your displacement vector. This is your displacement vector. So now what is the magnitude of this? So what is asked? So see, if you see the option, the magnitude they are asking you. So what is the magnitude of this vector? So PQ vector, you can take mod. So it is going to be root over 5 square plus 2 square plus 2 square. So that is 25 plus 8, that is root over 33. Root over 33. So this is going to be the A option. I hope it is clear to everyone. Please answer me. Yes or no, Buddha? Please answer me. Did you get this or not? Please answer me. Yes or no? Please give me yes or no. The live student can respond to me, Buddha, on this. Yeah? Is it fine or not, Buddha? Yes or no? Okay, I hope it is fine to everyone. Now let's move to one more question, okay, of the same context. So we have 2 point charges. We have 2 point charges. 2 point charges Q1 and Q2. 2 point charges Q1 and Q2 are placed at 0, 0, 0 and 1, 2, 2 meter respectively. Okay. See, this is very, very useful concept. Okay, respectively. Now they repel each other. They repel each other. They repel each other with a force, with a force of 3 Newton, with a force of 3 Newton. The force on Q2 due to Q1 is F21 as xi plus yj plus zk. Okay, Newton. Okay, Newton. Find value of, find x plus y plus z. Okay, find x plus y plus z, and we have the option 3, 5, 7 and 9. Please go for it. Can we please try this one? Can we please try this one? Please answer me. So see, 2 point charges are there, Q1 and Q2. Please try to answer it. Are placed, so their position is mentioned. They repel each other with a force of 3 Newton. They repel each other with a force of 3 Newton. The force Q2 on Q2 due to Q1 is, F21 is this. F21 is this. Now can we please try to answer this question? Okay, magnitude is given. Let's see if we can do it or not. See, if we are able to find this vector f21, definitely we'll be able to find x, y, and z. Please go for it. Let's try to do it. Let's try to do it. Please go for it. The live students can respond to the question. Please go for it. Now what it is going to do, how we are going to deal with it. So we have 2 point charges Q1 and Q2 are placed at 0, 0, 0 and 1, 2, 2. So we have 2 point charges. Let's suppose one charge is 1, another charge is 2. Okay. Okay. I place the 0, 0, 0, 0, 0, 0 and 1, 2, 2 and 1, 2, 2 meter respectively. They repel each other with the force of 3 Newton. Okay, very well. Okay, and the force of Q2 due to Q1. So now this is going to be F21 now. Okay, the force of Q2 due to 2, 1. Option C. So you have given option C in this question. No, beta, that's wrong. Okay, let me solve it for you. Let me solve it for you, beta. Okay. Now please understand this. So there are two charges. One position is this, another position is this. Now F21. So what does that mean? So it means that this is the force on 2 due to 1. This is how we are writing the force. So when we write F21 by default, it is the notation that the force on 2 because of 1. Are you getting my point? So this is going to be F21. Okay, and this F21 is given as X I cap plus y j cap plus z k cap, z k cap, and the position of these two vectors are there. Okay. Now please understand this. Please understand this. Now what will be? So we know. See, when our so force is a vector quantity. Now to give an vector quantity, to give a vector quantity, we are requiring two things. What? One is magnitude, other is direction. So magnitude is mentioned in the question 3 Newton. The magnitude is mentioned in the question, that is 3 Newton, and what is going to be another thing? So it will be the direction. Now, let's suppose this point is A and B. Now, this is 1, 2. Let's write 1, 2, no worries. Now, do you realize, Ramandeep, hello, my dear. So, Ramandeep, what we are doing, I'll tell you briefly. So basically, we are dealing into the kinematics. Okay, first of all, welcome to the session and welcome to the channel also. So my name is Dr. Umashankar, and here we are dealing with the vectors. Okay, so on this channel, we are trying to complete the physics as soon as possible. And what we are trying to do, we are trying to cover multiple chapters together. So in this direction, I have completed units and measurement in this channel, and also I am into this kinematics. So we are running two things together. One is motion in a straight line, one is vectors, right? Okay. So right now we are trying to understand the position and the displacement vector. So this is the last question in that, and afterwards we are moving towards the multiplication of vector. Okay. So this is what we are doing, and as the teacher, I must introduce myself also. So this is about me. Okay. So you can have a read over it. Okay. So basically, I'm taking PhD from IIT Roorkee, and these are some small credentials of mine. Okay. So let me come to the point. Okay. So as I was saying, so now see, so whenever you are giving any vector quantity, you require to give its magnitude and you require to give its direction. Okay, we know it. So the magnitude is given in the question, that it is 3 Newton, and we will be requiring that direction. Now the direction of this force will be in the direction of this displacement vector. Let's call it 2, 1. Okay, 2, 1 can also be a vector, na? Point 2 and 1. So if it has been AB, I would have written AB. Okay, AB. So I can write 1, 2 vector. So this is nothing but the I must write like this now, 1 to cap, okay, because unit vector, because we know that the unit vector gives the direction of something. Okay, so what is the direction of this force? This force is in the direction in which these charges are, isn't it? Did you get my point or not? Okay, so this is one charge, this is another charge. So the force direction will be from 1 to 2. Okay, so what we need to do with it? This is your force vector. Now what we can do, so what is going to be this displacement? So what is 1 to cap? This is the unit vector in this direction. Okay, unit vector in this direction. So we know this is 1 2 upon mod of 1 2. Okay, so don't confuse by the number. If you want, okay, I'll just give them some names now. Let's say this is A also, this is B also. Otherwise, what happens that we get confused. So this is going to be AB cap. Okay. Now, what is going to be the AB cap? This is going to be AB vector upon mod of AB. AB vector upon mod of AB. So this F21 is going to become, this F21 is going to become 3 times. Okay. AB vector. So AB vector is 1I. Okay. Plus 2j plus 2k. Sir, how come how you have written it directly? So we have done it multiple times. Na? See x2 minus x1, y2 minus y1 and z2 minus z1 upon the magnitude of it. So it is going to be root over 1 plus 4 plus 4. 1 plus 4 plus 4. So this is going to be 3 and it is going to be I plus 2j plus 2k by 9. Okay, by 9 root 9, so it is going to be 3. So we are getting I plus 2j plus 2k. So this is going to be your force vector. This is going to your force vector, but in the question, sir, it is given as x, y, and z. So you can compare. So x is equal to 1, y is equal to 2, and z is equal to 2. So x plus y plus z is going to become 5. I hope it is clear to everyone. Yes or no? Please answer me. Did you agree to it or not? Please answer me. Shivesh, you have given C option. Okay, did you get the mistake? Two charges are there. Okay, two charges are there. Let's say one is here, one is here. Now, this is the direction of force. So, this is also the direction of displacement vector. Na? Okay, so this is how you can use to get the displacement vector even in your 12th physics, right? Okay, okay. Now, let's try. Let's start the new topic, that is the target for today. So that is multiplication of vectors. Okay, multiplication of vectors. Okay, very important, very useful, and this is going to be used in multiple chapters of the physics, that is the multiplication of vectors. Now the live students, please, I request you to give me a yes if you have understood all the concepts that we have done today. So basically in the last session, we have done the position and displacement vector. Now in this session, we have solved two questions of it so that we get some better understanding from this particular part of the topic, right? Okay. Now, now what is going to be the multiplication of vectors? How to deal with it? Very important concept, very useful concept, and one of the very major concept of the physics. Okay. Now, what is going to be the multiplication of vectors? I'll give you something. So first of all, let's start with very simple thing. Now, if a scalar quantity is multiplied with a vector quantity, if a scalar quantity is multiplied with the vector quantity, what is going to be the result? The result is going to be scalar or a vector. If a scalar quantity is multiplied with, if a scalar quantity is multiplied with a vector quantity, so sir, you would say, sir, definitely and obviously the result is gonna be a vector. The result is gonna be a vector always. So we have done this before also, right? So we have multiplied now. So if we write a vector as, let's suppose, 3 times I plus 2 times j plus k. And if we write 3 of a of vector, so this is 3 is a scalar quantity. So we multiply it right away. that is 9 of I plus 6 of j plus 3 of k. So you would say that there is nothing new. We have been doing this ever since, and this is already we know, right? Okay. So remember the product of scalar and vector is always a vector, right? Product of a scalar and vector is always a vector. Okay, like for example, anything you can see. So if you see that a mass is there, right? So if you want to have a feel of it, so if mass is there, if mass is there, the mass is there, and if you are having some acceleration in this direction, so acceleration is a vector, acceleration is a vector, and mass is a scalar quantity. This is scalar, this is going to be vector. Now we understand that when these two are multiplied, we get the force, which is again a vector. So see, the result of the multiplication of a scalar and vector is always a vector. Okay, so this we already knew. There is nothing new you are telling us in this, so we already know. Now let's come to the next part. That is, so when we are multiplying two vectors now when we are multiplying two vectors, okay, what is going to happen? Now when we are multiplying these two vectors, okay, what is going to be happen? Now sir, vector and vector multiplied, will it become a scalar, will it become vector? So basically, please understand this, so there can be two kind of results from here. So these two when multiplied, and now this is not the cross, okay, don't take it otherwise. I'm just referring to the multiplication. Okay, this is multiplier. Okay, this is our operator of multiplication. Don't feel that this is, sir, you have written the cross product. The cross product sign is same. So I'll just write this. Okay, star. Okay, star, not multiply. Star. But star, so see, like in computer or in, so if you are using some laptop or computer, if in the computer you have to use the multiplication, you use the star. Na? Okay, so remember, so don't confuse it with the cross product. Okay, so when two vectors are multiplied, guys, so the final result could be a scalar as well, and the final result could be a vector as well. A vector as well. So now in the cases where the vector and vector multiplied and they give the scalar result, this is also known as the scalar. This process is also known as scalar or dot product. This whole process is also known as scalar or dot product. And whenever we are having two vectors multiplied and we get again a vector, so this is going to be called upon as a vector or a cross product. Okay, okay. So this cross and this dot, these are basically operators, okay, which are giving you this idea that how we are going to do the multiplication or finally getting the result out of multiplication. So you can consider these are the two ways of multiplying the vectors. These are two ways of multiplying the vectors. Okay, I hope it is fine to everyone. Right. Now, please understand this. Understand this. So, see, let's talk about firstly the scalar product or the dot product. A scalar product or dot product. So, one simple information I have given to you that two vectors can be multiplied, and when they are multiplied, there can be two different solutions to it. One is the solution in which you are getting finally a scalar quantity, and one is a way in which you are finding finally a vector quantity. Okay, okay. So what could be the examples of it? Now see, scalar product. If I say so, see force. Okay, force and displacement. Both are vectors. Both are vectors. See, now please understand this. I'll come up with this. Like, see, force and displacement. Force and displacement. I'm just trying to give you a feel. Force and displacement both are vectors. Now, when they multiply, you get the work. Okay. work. And we, I guess, very well know that work is a scalar quantity. This is scalar. This is what? This is a scalar quantity. Now, see, two vectors are multiplied, you are getting a scalar product. So, a scalar, so that means it happens to be the dot product. Okay, it happens to be dot product. See, in general, like we say, force into displacement is work, but actually, force and displacement, they are having the dot product. They are having the dot product. So, here you see two vectors multiplied. This is a vector, this is also a vector. So when two vectors are multiplied, we are getting the scalar quantity. Okay, like for example, power also. Okay, power also. So like for example, force is a vector. Okay, force is a vector obviously, and velocity is a vector. Now both multiplied, that means we are getting the power. Power is also a scalar quantity. Power is also a scalar quantity. Are you getting my point, beta? Are you getting my point? Okay. Now, whenever you are multiplying any two physical quantities which are vector, but the result you are getting is scalar, remember that you are doing the dot product. Okay. And similarly, in case of cross products, okay, so I'll write here. So, for example, force multiplied with distance from the x. So I'll come up with this r later. Don't get confused. So this is also a sort of displacement. So when force is multiplied by this distance from the axis, this displacement from the axis, you get torque also. And torque is a vector quantity. Torque is a vector quantity. Now please understand this. So torque is basically a form of force actually. Are you getting my point? So normally we represent it like this. Okay, tau. Okay. So I have placed the sign of the vector. So this is also a vector. So now two vectors are getting multiplied. Okay, two vectors are getting multiplied and you are getting a vector. So that means in torque what happens? There is a cross product. You happen to do the cross product between these two vectors. So this is the operator. See, this is dot cross. So at times in general, see, we many times use dot. We many times use this sign of multiply. But there, acha, she said you are here only. Okay, okay. So you are getting the point, huh? You were not saying something, so I thought whether you are here or not, I was not pretty sure. Okay. Uh, so now two physical quantities, when they are multiplied to each other, if they are vectors and the result is also vector, that means you are doing the cross product. So I was saying like in general, what happens like when we are multiplying two things, we use dot, we use cross. So in general algebra, that is okay. But in vectors, there can be a difference to it. In vectors, there can be the difference to it. Understood, beta? Understood? Now let's talk about what is the scalar product and what is the vector product. Acha, acha. He's like, noted, no problem. Okay. Now, what is the scalar product or the dot product? So let's suppose we are having two vectors. Now, see, we have to be understanding this very patiently because see, this is the basic to many things, and we are not want to make any mistake here. So now two vectors. Let's suppose one vector is A, one vector is B, one vector is B. So you want to do the dot product of it. You want to do the dot product of it. So see how we can do it. So I'll give you the formula first, then we'll try to interpret this. We'll try to interpret this. Now see, A dot B. So if you want to find it, simply you need to take the magnitude of A vector, you need to take the magnitude of B vector and multiply it with cos theta. So if you are doing the scalar product of some vector, you are going to do A vector B cos theta. Are you getting my point, Vida? Are you getting my point? Is it fine? Okay. Okay. And it has no direction, obviously. So you are getting the scalar product. Yes or no? Please answer me. Please answer me. Yeah. Do you agree? Do you agree? Okay. I'll give you the physical interpretation to it. Don't worry. Okay. Just first try to understand the formula. So very simply, we can say, yeah, yeah. She said, please ask. What is the question you are having? I'm waiting. Direction disappeared. I'll tell you. I'll tell you. Please understand this. She said, first of all, see, this is what I said, this is the formula. Okay. AB cos theta. AB cos theta. Now please understand this. Now please understand this. I'll try to explain this with the help of example also, with the help of physical quantity. But sir, when two vectors dot product, so I understand that what you are saying, that where is the direction gone? Now please understand this. Please understand this here. First of all, what is it? If I write b cos theta, so A. Now please observe. See, this is A. This is your A vector. This is your A vector, and this is, let's suppose, your B vector. Now give me one thing, Shisa, yes or no, that you understand that the length of a vector is the magnitude of that vector. Do you agree to it? Yes or no? Please answer me. The length of a vector is magnitude of a vector. Wonderful. Now when I write A and when I write B cos theta, so do you realize that this is B cos theta? This is B cos theta, isn't it? This is B cos theta. Yeah. Yes or no? Okay. So basically, what you are doing, beta, what you are doing, you are multiplying the component. You are multiplying the component of a vector to another direction. Are you getting my point? You have taken the component of B, you have taken the component of B vector in the direction of A, and then you are multiplying their magnitudes. Are you getting my point? This is the dot product. This is the dot product. Yeah, KM. Please answer me, Bida. Please ask me. Okay. Now, like for example, I have quoted this work. Okay. This quoted is work. So, what is work in general? If I ask you to define the work, she said, what would be the work in general? Sir, it is force into displacement. No, 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 no. It is force and displacement, force into displacement in the direction of force. Are you getting my point? Yeah, Kim, you can always ask me the doubt. Please understand what is work. What is work? Work is something, it is force into displacement in the direction of force, and vice versa. Like displacement into force in the direction of displacement. Are you getting my point? So when you are finding the work, you are interested in having the magnitude of displacement, okay, magnitude of displacement and magnitude of force in the direction of displacement. Are you getting my point? Please answer me. I think it is going to be clear now. Now see, come back here. Now this is vector A. Let's suppose this is force vector. Okay, and this is vector B. Let's suppose this is displacement vector. Okay, so when you want to find the verb, so won't it yield a common direction? No, 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 no. That is why I ask you. See, what is work? How can you define work? Is it force into? Is it force into the displacement in the direction of force? First, tell me, do you agree with that or not? And does it require any direction? Work, does it require any direction? Do you have any doubt that work requires some direction? Hmm? Okay, so you believe that work do not require any direction. It's just requiring the multiplication of force with the displacement in the direction of force, or it is just the multiplication of displacement and force in the direction of displacement. Then you get the work done. No doubt in that. Magnitude. Magnitude. Not there. When you don't have the doubt in this, how come there is a doubt in this? That you are using the magnitude of this vector A and magnitude of the component of vector B. Are you getting my point? In the direction of it. Okay. Let's say we have a vector force F. Okay. Let's try to understand this with the help of work. Okay. And this is the direction of the displacement. Okay. Okay. Now you only said, sir, work is force magnitude and magnitude of displacement in the direction of work. Yes or no? Displacement in the direction of work. Sorry, in the direction of force. Yes or no, beta? Please answer me. Do you believe in this? Do you have any doubt in this? Again, I am asking you. Kim, I am waiting for your doubt, my dear. You don't have any doubt in this, right? Okay. If you want, I will explain this also. Okay. Okay, I believe you. You don't have any doubt in this. Now, force. What is the magnitude of force? So this length, na, the length of this vector. So can I write it as F? Okay. So in this way, force is also requiring the direction. Please understand this. This is a mod. Na? That is why I asked you that do you have any doubt in the force? Okay, you are confused in this. Okay, let's come back to that again. See, she said, just think and tell me one thing. Work is force into displacement. Please answer me. Yes or no? Force into displacement. And displacement has to be in the direction of force. Isn't it? Yes or no? Do you agree to it? Now, to get the force, we require the magnitude of force and the magnitude of the displacement in the direction of force. I think you missed this thing. What? See, when two vectors are multiplied, it is not necessary that they always give the vector. Acha, acha, you missed this point. Now you came late, na? You say it's not necessary. What you are saying, sir? It is not necessary that a vector multiply will give us the vector only. Acha, Shivesh. No, 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 Shivesh. Two vectors. So see, first of all, multiply. It's quite confusing. Don't worry. Okay, we'll clear all that out. Two vectors are multiplied. The result can be scalar and result can be vector. Acha, 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 acha. Shivesh, no, 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 Shivesh, not ignoring you, but I just thought the messages of Shisai. Arey yeah, Shivesh, I'm really sorry. Actually, my mobile is it is out of charge. I'm really sorry. I'm really sorry. My mobile is out of charge, na, so you see I'm seeing like this, na. I'm seeing like this, na. So I'm seeing my mobile from very far, and see how I see your chest. I'll tell you frankly how I see your chest, guys. So I see your chest through. I play the video in my mobile, and I see the chat. So I am very much involved in reading the comment rather than seeing the name. Shivesh, I am really sorry, my dear. I am not ignoring you. See, as a teacher, you all are equal to me. Okay. Okay, it's just that you have come in between the doubt of the Shrishai. So I thought if Shrishai is adding into his doubt. Okay. Okay, that is why I was wondering that Shrishai is saying no, sir, no doubt. Then he is asking something. Okay. 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 Let me clarify this. Okay. Let me comment. This is going a little bit more confusing now. Okay, because of my this silly mistake. Okay, teachers also make mistake. Now we are human beings only. See, first of all, let me come back to this. See, is scalar multiplied to vector always a scalar? Vector multiplied with vector can be scalar, can be vector. Okay. Now the first thing that we must know from our heart that two vectors multiplied can be a scalar, can be a vector. So if two vectors multiplied is a scalar quantity, that scalar wouldn't be requiring any direction. Okay. Now in the quantities like work, power, that is why I was explaining here. In the quantities like work and power, even though two vectors are getting multiplied. The result is not a vector, so we are not at all concerned about the direction of the result because it has no direction. It is scalar. Is it fine? Yes or no, Shivesh and Pisai? Yes or no? Thank you, Shivesh. Yeah, please answer me. Two vectors when multiplied, the result is a scalar, so there is no direction to the scalar. Understood, beta? Please answer me. Yeah, just give me a yes on this, both of you. And any other student is present in the class, he can also come in between. Yes or no? Both of you. Then I'll move forward. Otherwise, it will go very confusing. Yes or no? Please answer me. Waiting for your responses. So two vectors multiplied, if the result is a scalar, we are not doing anything with the direction of the result. There is no issue in that. Now please understand this. So what is the scalar product? So let's come back to the formula. So when two vectors are multiplied, the result is going to be, so vector A multiplied by means vector A dot product with B, the result is going to be the magnitude of A, magnitude of B and cos theta. So it has, the result has no direction. Result has no direction. Now to answer this query, that the what happened to the direction, what happened to the direction, the direction is nowhere to be seen here. Now in that case, what you are doing, see, I'll explain again. So see, this is, let's suppose, of vector f, and this is, let's suppose, of vector s. It's fine. Okay, wonderful. This is vector x. So this is force, this is displacement. Now, in the case you want to get the work, so work is going to be the dot product of force and dot product of this displacement. Dot product of this displacement. And by the definition of work, we understand that it is the magnitude of the force and magnitude of the displacement in the direction of force. So what is the magnitude of displacement in the direction of force? So sir, we know this is x, and if we take component, if this angle is theta, if we take component of this in the direction of f, it is going to be x cos theta by the magnitude. X cos theta by the magnitude. Okay. Okay, so this is the magnitude of f here, this is the magnitude of x here, and this is going to be cos theta. So basically we are using the magnitudes only to get the scalar product. Yeah, right? Yeah, perfect. Perfect. Now remember, again I am writing. So two vectors, when you are doing their scalar products, you can write it like this: A, B cos theta, A, B cos theta, or you can write it like this also: A, B cos theta. Okay, because we know from the representation of vector, AB cos theta. So when I write this A only, that means the magnitude of A vector. When we write B only, that is the magnitude of B vector. Clear, beta? Clear? Now I think this is clear. So now let's move to some special cases, some special things. So this must be like, you must be very handy to it. Okay. This will help you to realize many things. Yeah, very easy. So now if the angle between two vectors is 0, if the angle between two vectors is 0, now do you think that if the angle between two vectors is 0, so their dot product is going to be what? AB cos theta. So cos theta, that is cos 0, that is AB. So two vectors in the same direction, two vectors in the same direction, they are going to give you the result as the simple algebraic multiplication of their magnitudes. Okay. Now what happened if theta is equal to 180? Okay. 180, because we know that A dot B in general is AB cos theta. Shivesh, please do tell me if you have any doubt. Okay, now if theta is 180, that means cos theta is 180. So cos theta is going to become how much? It is going to become minus AB. Okay, minus AB. Okay, okay, okay. Now please understand this. Now please understand this one thing. What is the maximum value of cos theta? What is the maximum value of cos theta? What is the maximum value of cos theta? So maximum value of cos theta, we know that it is plus 1 and minus 1. Now, do you believe that this is the maximum value in positive? See, these important, very important points. Yeah, Shivesh. So this is maximum value of the dot product of A and B, right? In a positive, right? And again, this is the maximum value. This is the maximum value of vector A dot vector B in a negative. Do you agree to it or not? Please answer me. No, very, very important case. Very, very important case. Then if theta is equal to 90 degree, do you realize that A dot B is going to be 0. A dot B is going to be 0, right? Because cos 90 is 0. Cos 90 is 0. Okay. Okay. So two vectors, if perpendicular to each other. So you must remember this. Okay. Two vectors, if perpendicular to each other, if perpendicular to each other, their dot product is going to be 0. Their dot product is going to be 0. Yes or no? Now, physically, please understand this. So, if force is acting in some direction, it can never move that body in the direction perpendicular to the direction of force. Are you getting my point? Please try to understand this. Okay. Okay. If a force is acting in some direction, it cannot displace the body in the direction perpendicular to that direction of force. Agreed? Yes or no? Okay. So remember this thing. If dot products of and vice versa thing, reverse of it. Yes, yes, I am repeating myself. See, this small concept has so much physical interpretation, that you are going to see later. So when we have these things in clarity in our mind, we are going to excel later. Okay, okay. So please understand this. So if a force is acting on a body, okay, let's suppose a force is acting on a body in x direction. Okay. Now it means that the body can never move. Okay. In a way, it can never move due to the effect of that force in y direction. Are you getting my point? Because x and y are perpendicular to each other. X and y are perpendicular to each other. So when x and y are perpendicular to each other, force and the displacement due to that force can never happen in the direction perpendicular to it. This is what I mean. Are you getting my point? This is what I mean. Understood? Okay. I think I made it too complicated. See, if the force is in this direction, let's suppose this is the direction of the force, okay, just trying to tell you the physical relevance of it. Okay, later on when we'll talk in this, we'll be talking about it. Now see, you cannot have the displacement. You cannot have the displacement of this body in this direction. Are you getting my point? Why? Why? Because if you do the dot product of these two vectors, it is going to be 0. So there is no work done. There is no work done. So no work done, that means this body simply cannot move. Any body cannot move in the direction perpendicular to the direction of the force. Are you getting my point, beta? Are you getting my point? Okay. You got it now. Okay, so I don't want to confuse you, just trying to tell you the physical interpretation. That's all. Okay, that's all. Okay, okay, and this thing has to be handy. Shivesh, are you getting the point now? Huh. Displacement into force. If displacement is perpendicular to the direction of force, then dot product is zero. That is work done is zero. Shivesh, you are also getting the things now. Okay, okay, okay. Now this is going to help you at many places. So if you have a vector, let's suppose you have a vector I plus j, I plus j. Okay, I plus j. Now, if I want to ask you that what is going to be the vector perpendicular to this vector, can you tell me a vector perpendicular to this vector? Sir, we don't know how to do the product. I'll come to that. But see, I'll tell you. I'll tell you, see, if you have this information, you can say that perpendicular to this vector is I minus j either or or I minus j either or minus I plus j. Minus I plus j. These two vectors are perpendicular to these two vectors. Are you getting my point? And obviously this I plus j is not here now. Are you getting my point? Okay. So see, this concept is going to, because see how I have done it. So if you dot product these two vectors, you are going to get zero. If you dot product these two vectors, you are going to get zero. So this is going to help you to get a vector perpendicular to any vector. Are you getting my point? This is going to help you to get a vector perpendicular to another vector. So there are many uses. So this must be in your memory. Understood, beta? Right? Wonderful. Now, simple two more things. So if what happens if theta is less than 90? What happens if theta is less than 90? So if theta is less than 90, the A dot B, so this will become AB cos theta. Now very simply, sir, if theta is less than 90, that means cos theta is positive. That means cos theta is positive. So if the angle between two vectors is less than 90, the dot product of theirs is always positive. Okay. Now similarly, if theta is greater than 90, if it is greater than 90, so it would be less than what value? If theta is greater than 90, it would be less than what value? Can you answer me? If theta is greater than 90, then it would be less than what value? Shivish, and she said, please answer me. No, no. I am asking if theta is greater than 90, it would be less than what? It would be less than what? If theta is greater than 90, it would be less than what? Please answer me. So, sir, obviously, if theta is greater than 90, it should be less than 180. Na yaar? Please answer me. Theta is greater than 90 and it has to be less than 180 because less than or equal to 180 because what is the angle between two vectors? It is always less than 180. This is what I mean. This is what I meant. Are you getting my point? Because now people, students start relating that if it is going into the third vector, what is going to happen? If it is going into the fourth vector, fourth quadrant, what is going to happen? So there is nothing like that. Okay, it will be either 90 degree, less than 90 degree, greater than 90 degree, 0 or 180 degree. So now in this case, what is going to happen? In this case, this is going to be negative. This is going to be negative. Okay, I hope it is fine to you. So guys, see, something urgent have come up just now. Okay, so I have to stop this session. And see, so we have introduced you with the dot vectors and the position and the displacement vector also we have seen today. Okay. So I'm really sorry. I wanted to complete this dot product today itself. Okay. But something come up. Uh, some work is happening in the home. Okay. So now the people who have to do the work are here, and I have a dog. So he start doing nasty things. Right. So uh, sorry for today. So in the next section, I'll complete this dot and cross product together. Oh, it will be too long. Okay. I'll try to finish as much as possible in the next section. Sounds good? So thank you very much. Have a good day. Please do subscribe the channel and we'll see you in the next session. And don't forget the introduction I have given you to the dot product. Okay. I'll take it to the next level in the next session. Okay. So have a good day. We'll see you in the next session.